Hardy-Weinberg equilibrium equation is a theory developed by G. H. Hardy and W. Weinberg. It explains that the evolution could be described as a change of the frequency of alleles in an entire population. P refers to the frequency of the first allele or allele A, and Q refers to the frequency of the second allele or allele B. There are two equations for Hardy-Weinberg equilibrium equation, which are P plus Q equals 1 and P squared plus 2PQ plus Q squared equals 1. The 5 conditions for a Hardy-Weinberg equation are an adequately large population, a random mating, no mutation of the alleles, no migration between alleles, and no natural selection. For a real-life example, if the question asks if 98 out of 200 individuals in a population express the recessive phenotype, what percent of the population would you predict would be heterozygotes? For this question, you can simply use the equation, which is p squared plus 2pq plus q squared equals 1. In this equation, p squared refers to the frequency of homozygous dominant genotype, 2pq refers to the frequency of heterozygous genotype, and q squared refers to the frequency of homozygous recessive genotype. Since q squared equals 98 out of 200, which is 0.49, we can calculate that q equals to 0.7. And using the first equation, which is p plus q equals 1, we can know that p equals to 0.3. And with the values of p and q, we can calculate that 2pq equals to 0.42. So we can conclude that 42% of the population is heterozygous.